let's get started. So as I was saying, my name is Ed Kazarian. I teach in the Philosophy and Religion Studies Department along with Professor Lund. I am the coordinator of the Theorizing and Rowan series. And I am very pleased to welcome all of you here. With that said, I want to introduce Dr. Matthew Lund. Professor Lund has his PhD from the University of Chicago. The University of Illinois at Chicago. I always do this. I know. And some of us have our PhDs in the University of Chicago, but you know, it's very confusing, all these people in Chicago. Anyway, UIC, in 2004, he has taught at Rowan since that same year. He is an associate professor in the Department of Philosophy and Religion. He has a book on Norbert Russell Hansen, important 20th century philosopher of science. The book is called Norbert Russell Hansen, Observation, Discovery, and Scientific Change. And Matt is also working on editing and sort of producing reissues of a number of Hansen's posthumous volumes that came out originally in the 1970s and have been unavailable since then. He works as, you know, the topic of this lecture, in fact, is related, and as well as that publication, he works a great deal in philosophy of science, but he also works on sort of history of philosophy, German philosophy, history of the 19th century, and philosophy more generally. He's taught, you know, courses on Nietzsche and American philosophy and American pragmatism as well. It gives me great pleasure to welcome Professor Lund, who's going to speak to us today on the subject of whether expertise must be confined to the facts. Please, everyone, welcome Professor Lund.
Thank you. Thank you very much, Ed. I appreciate it, and thank you for everybody coming. I'm quite happy to see so many people here. Maybe I'll be a little bit nervous to begin with, but I'm sure I'll get over it. So let me just explain before I begin sort of, I don't know if you guys can see this yet, it's still kind of coming on, but I have a PowerPoint that I'm going to show you, but I like to talk. I don't like to read things. I don't like to listen to people read things. You might feel the same way about it, so I'll try to talk in an articulate, interesting way, and if I say anything that you find totally obscure or idiotic or incoherent, you can always ask me a question. I encourage that. I find that I communicate better if I don't just talk, you know, continuously for an hour. So I hope not to do that, but what I've tried to do with this talk is, this is a talk that began with some examination of some really forgotten arguments by Norbert Russell Hansen, as Ed was talking about to begin with, the person I study the most. I study him more than anybody else ever has. And I ended up really wondering at some arguments that he left behind from the late 50s. And these were arguments that were very specific to the history of science and the methodology of science. And then as I worked on it more and more, they became less and less confined to just a scientific domain. The problem seemed to be one that would exist in all realms of knowledge, and that is, you know, how do we really assess whether someone's an expert or not? What does expertise really fundamentally come down to? And as I read more just straight up epistemology on this, I was really sort of disappointed by the kinds of models of expertise that epistemologists would give, because they would just say, you know, A is an expert in some field if A knows that P in all the different P's that field encompasses, or something like that. It's a case of knowing a whole bunch of specific little facts. And it seemed to me that real genius or novelty or great discoveries are not the product of somebody just knowing that P for all the various P's we could enumerate. It seemed to have to do with something different than that. And so this talk really grew out of a very small concern within philosophy of science, and I think it brings up a lot of interesting consequences for lots of different fields. You know, how is it that we think that, you know, people who are economists who tell us how the markets are going to do, how do they get their expertise? Do they know that P? Do they know all the facts about the future in markets? Of course they don't. What is it about the way they approach that subject matter that really makes them experts? Okay, so can everybody see this okay, or is it possible to kill the lights a little bit more? I imagine people in the back can't see it too well. Is that okay? Maybe that's a little bit better. Okay, so let me just give you a little breakdown of my talk then. I'm going to talk about why these arguments from authority or arguments from expertise are important in scientific discovery. And I'm going to distinguish two different ways of construing appeals to authority. One has to do with matters of fact, and the other one has to do with inquiry. You know, what's the best hypothesis? What's the best hunch? What's the best way to go with some problem situation we're trying to settle? And what I want to say in the next section is that there are a lot of cases in the history of science where very good and worthy hypotheses have been lost. There are lots of cases where someone's come up with a hypothesis and it's been premature in the sense that it could not be tied into canonical knowledge in that area at the time, and a lot of these things end up getting forgotten. So what I'll do there is I'll make a prima facie case that we should take the history of science very seriously, and we should be open to the possibility that our knowledge in science is maybe not as good as it could have been because we've lost things. And why did we lose them? And the kind of argument I want to make is that many of these cases show that people who were experts were sort of stopped from examining some hypothesis or other, either due to their own diffidence or because they died early or because they didn't have the data at their disposal they needed to prove something, a variety of reasons. And that were we to run history again, maybe things would have been better if those things had been inquired into, maybe by other people when some of these people had died. And then I want to do a more sort of logical analysis of what it is that make appeals to authority, especially in this special domain where there aren't facts to confine things, what makes them legitimate. And then I'm going to look at a couple of cases of hypotheses that scientists had come up with, but they didn't bother to test, but that still seem to be very worthwhile. Okay, so that's kind of a general overview of what I'm going to look at in the talk. Okay, and I apologize for this slide in advance. There are too many words on it. Don't feel obligated to read any of them. Let me just talk about what's on here. So let me talk just for a moment about Nord Russell Hansen. Nord Russell Hansen was a very dynamic, sort of almost a titanic sort of character. He was a very talented philosopher, and he was also a very talented musician. He was a talented boxer. He set the Oxford County shot putting record when he was going to graduate school. He was a great visual artist as well. He seemed to do almost anything, and he was also a pilot. He was a stunt pilot after his experiences in World War II, and he ended up doing all these air shows and became something of a minor celebrity, and then he ended up killing himself in a plane crash. Actually, the third plane crash that he experienced, and it was fatal. And so he was kind of a wild man, and one of the interesting things about Hansen was that he was very, very influential on other philosophers of science, especially Thomas Kuhn, who's well known outside of philosophy and history of science. But Hansen's own philosophy got sort of forgotten because he died at a time when a real critical following of his work could have been really starting, and then he died and fashions changed. And one of the things Hansen had argued back in the 1950s was that there can be good reasons for putting a hypothesis forward before you do any testing at all. And this might sound to you like just a commonsensical truism. We might all believe this to be true, but the philosophers of the 20th century had believed that there is no rational way to come up with a hypothesis to begin with. There's nothing but this sort of psychologically confused state where some idea might arise, and if that idea has testable implications, then you can go out and test the idea, and then you can see what happens. But before the testing happens, there's nothing you can say about whether this is a rational hypothesis or not. And Hansen kind of wanted to dig deeper into the processes of creativity, and he wanted to say, no, there are good reasons to put a hypothesis forward to begin with, even if you don't have any data whatsoever. And so some of these were more important than others. He gave a couple of different general types of logic of discovery. He talked about arguments from analogy or arguments from symmetry. And he also mentioned arguments from authority. And he said if you appeal to the right kind of authority, then your argument may be justified, even if you haven't done any testing yet. I will argue later, towards the end, if I don't run out of time, that arguments from authority that are legitimate are just cleverly disguised, what philosophers call abductive arguments, going back to C.S. Peirce, which means that they are arguments which put forth premises that, if true, will explain recalcitrant phenomena. They'll be able to explain things that we can't yet explain, and that's the reason why we think they're legitimate. And so it just happens that some authority had entertained the hypotheses or the arguments that compose it, and if somebody else were to come along and consider these, they would be rational to do so. Okay, so let me talk a little bit about different ways of understanding appeals to authority. So I mentioned this in the preamble that every analysis I've ever seen really confines itself to authority being reducible to someone's knowledge about matters of fact. So if someone's a doctor, that person has authority over all kinds of exotic areas of inquiry that most of us don't know about. Your mechanic who works on your car has an expert knowledge about all of those items that you and I don't really have. And so they attempt to do this kind of reductive definition where what it is to be an authority just means you have a lot of knowledge. And I think in general this is something we test in accord with this. You know, if I want to tell if somebody really knows anything about history, I can ask them certain questions, and if they know that P in all the areas I think they should, then I think they're smart enough about it or something like that. But I don't know that it really captures everything that's interesting about authorities. So, you know, we can talk about historical events. We can, if I was a scholar of the French Revolution, I might want to know why Jean-Paul Marat was murdered. We can talk about all these scientific facts that you encounter in science courses, you know, and if I know all the facts about the periodic table, maybe that makes me an expert of some kind. But it seems like there's something more than that that really makes you an expert. And, you know, people we consult, we tend to think that they're experts because they know things, but their expertise may be something better defined in terms of things that they can do or problems they can solve, inquiries that they can go through and do certain things. So I think it's sort of unfortunate that people have gone in this direction of just thinking it has to do with knowledge of facts. And I also think that, you know, if you read some history of science, it's fascinating to us to wonder, you know, what other things would Darwin have done, for example, if he wasn't so sickly his whole adult life? What other kinds of views did he have that he didn't publish? We find this with Isaac Newton, that he spent an awful lot of time not writing anything. He didn't like to share things that he believed. He thought people tried to steal things that he believed. Lots of things were kept cooped up in his head. We don't know anything about it. And why are we interested in these things? You know, so Darwin, for instance, had done a lot of work on heredity. He was a breeder of pigeons. He was trying to figure out what it was that was responsible for certain traits getting into the next generation. And he never got anywhere with it. He never succeeded. And so in Origin of Species, he just has to say, you know, I can't explain how heredity works. Fortunately, once a theory of genetics arose around 1900, as I'll talk about in a minute, and once you had a molecular theory of genetics in the 50s, it all sort of cohered very well with this theory. But we still would wonder, you know, maybe a good starting point for heredity, if I'm working in 1880, is to know what Darwin had to say about it, what he didn't publish about it. This next item is about the history of quantum mechanics. Einstein and Louis de Broglie both entertained ideas that the quantum mechanical interpretation that became a vogue interpretation, which said that there really is no information about the states of quantum objects in certain conditions. They found this to be unacceptable, and they wanted to develop hidden variable theories, but Einstein was never successful with it, and de Broglie was actually a very personally diffident sort of person, and he was sort of rebuked at a conference by a bunch of supporters of Heisenberg, and he just kind of didn't want to go any further with it. But we might be interested in just how much he might have developed had he been more confident about it. And the reason I will argue that we think these things are important is because we might think that individuals like Darwin and Einstein and de Broglie and Newton were authorities, and maybe there were good ideas that they had, good hypotheses they had that we would be well served to study and examine ourselves, okay? Okay, so there we go. So as I mentioned, one way of talking about this that's very common is to say that an authority, someone A, is an authority about P if A knows that P. So, you know, A knows these facts. I given you many examples in the previous slides. And then N, some novice who might come onto the scene, is justified in trusting A to the extent that one, that A is believed to be an authority about P by the right community. So this is kind of a social epistemological definition. If all the other physicists think that this guy's work is really good, then I'll just, you know, assume that they're right about that. And these terms are due to Philip Kitcher, a philosopher of science. It's from his book, The Advancement of Science from 1993. And he called the first one to be indirect calibration. I sort of come up with a view about someone's authority due to other people in the community's perspective. And then the second one would be that, you know, maybe I could go out and test these things for myself. I could verify that to the extent of my ability that this person actually knows what he or she's talking about. And that's what he calls direct calibration. So here would be an example. Back in the 1980s, there were reports of cold fusion, you know, nuclear fusion happening at room temperature. And what was complicated about it was that it involved expertise from a number of different scientific fields. And researchers went out and they tried to directly calibrate that research, and they found that they could not do so. They could not replicate those results. And so these two researchers, Pons and Fleischmann, therefore, were, you know, they had their careers destroyed by this. They were seen not as authorities any longer. But as I've been trying to urge, I think these accounts rely too heavily on the idea that knowing the facts is really what this is about. It seems like there's something procedural going on in all of this, that it's not just knowing what's true, but knowing how to determine what's true. And then on a more interestingly global level, it has to do with understanding where inquiry ought to go. What would be a fruitful hypothesis for us to start out with to solve some problem that we're dealing with? I'll return to Hansen for just a moment, and I'll leave Hansen behind very shortly. In Hansen's very first paper on logic of discovery, he said that authority is a legitimate, or can be a legitimate, part of the logic of discovery, but the justification he gave actually is explicitly based on the notion that we're talking about matters of fact. So he says, you know, mathematicians trust the logarithmic tables they work with, which of course people don't have to mess with anymore, it's all in computers. They don't work all of it out on their own. You know, so there's an element of trust, there's an element of going with authority even in these very rigorous academic disciplines like mathematics and also in science. Elsewhere though, interestingly, Hansen wrote an article about legal theory, and he was talking about the notion of an expert witness. And he had said, you can only have an expert witness if there is a stable field of facts within some area. You know, so if we want to call in a psychologist to, you know, say that somebody suffered from some disorder, but the disorder was not recognized by the whole psychological community as a legitimate one, then you wouldn't really have the capacity for an expert witness. And he made this case that expertise only really functions if you have a stable field of consensus. And if you have lots of disagreements like you might have in hidden variable theories in quantum mechanics, or like you might have had around the turn of the century about whether evolution proceeds by acquired characteristics or natural selection, you may not be capable of having consensus. You may not be capable of having expertise. And I want to argue that he was wrong about that. I think that you can assess, even if the community doesn't agree, you can assess the arguments that support the various views, and you can also look at what the consequences may be of those views if they're true, and you can examine those things. And you can see which side has a better argument even if you don't have all the evidence yet. Okay, so here's sort of my credo in a way. This is the kind of thing that I'm trying to argue for, that the most prized form of expertise in science involves problem solving and theory creation. While these activities crucially depend on the facts are a necessary condition to be able to get anywhere with those activities. they involve a sort of higher order capacity, which I think stands over facts as wisdom stands over knowledge. So wisdom is sort of having a broader, more reflective understanding of the things that you know than just knowing a lot of facts. And so in the same way, it may be that the important kind of authority we're looking for is one that can examine all these different ways of inquiring into some problem and see which one goes in the right direction. And so I'm borrowing a sort of nice metaphor here from epistemologist John Hardwig, who wrote a very influential article from the mid-'80s where he's talking about trust in science. And it's almost kind of a scandalous article in a way, because he was showing just as scientific research projects got bigger and bigger and you had more and more people involved, say you have, over 100 researchers with some of these experiments with subatomic physics, no one person really knows what's going on in the whole project. Everybody has their little piece they do, but nobody brings it all together. And he argues that some level of trust is entirely necessary in science. And a lot of the trust is illegitimate. So a lot of us think if something gets published, those results have been replicated and someone went out and checked it, but actually this doesn't really happen. You don't get nearly the reward for showing that somebody screwed up that you do for doing something right to begin with or something interesting to begin with. And he argued that trust is blind. I would say in these cases that our trust of an authority is something like being visually impaired. You can be legally blind and still be able to make certain discriminations. You might not be able to drive a car, but you could maybe pick your keys up reasonably well. Because lots of legally blind people have some element of vision. And so we might be not capable of fully understanding what it is authorities think. There'll always be some level of vagueness, some level of uncertainty, maybe a very large level of vagueness and uncertainty. But all the same, it might be a good guide in some situations. And so within epistemology, a lot of people want to come up with a social epistemology that just kind of says, okay, here's the kind of community we have, here's the kind of investigations they do, here's the way they share information with one another, and by and large, it works out. What I want to argue here is that we still may have cases where the old idea that you had a single very smart person, somebody like René Descartes or somebody like Newton, somebody who was capable of sort of pulling together everything in some area, we might still have a case where these individual hypotheses, these individual ideas about where to go are very, very critical. And maybe our social epistemology can't really filter all that out. Maybe there's a necessity to have some old-time individual knowledge claims in the center of science. Not sure if I like that to be true or not, but maybe I do. Okay, so let me move on. I'm now going to talk about things that I think are less philosophical, they're less wordy, they're less jargony, so I hope this is, meets your approval. I hope it's interesting. So we might look back in the history of science and we might ask whether things would have been different had certain scientists lived long enough to have articulated and pursued things that they had in mind, but they just couldn't, for whatever reason, they couldn't investigate it, they couldn't get the right equipment, they couldn't get the right data. Would things have been different? And I think the answer is yes. We'd like to think about history in a way where everything, especially in science, everything's going to work out right. Thomas Carlyle had this dictum that a lie can't stand forever, that eventually everything's going to come out in the wash and it's okay, we don't need to care about the history. I don't know that that's true. I think reading history cures one of that feeling pretty quickly in the history of science. There are a lot of contingencies, lots of cases where things could have went very, very differently. We might ask, would science have been different had the hypotheses a scientist articulated but didn't pursue been taken up and examined by other scientists? So say some authority, say somebody like Stephen Hawking, if instead of just becoming paralyzed and incapable of speaking, say he had died of his illness at a younger age, but had sort of somehow communicated what he was thinking things might look like. Would we be interested in examining that? Would that accelerate our development of knowledge? Would it fundamentally change the kind of knowledge we might get in the end? I want to say probably, okay? And so can there be good reasons for pursuing a hypothesis? I'm going to say yes, and I'm going to talk about some of those reasons in a moment. Let me talk about some interesting historical facts. So I don't know how well you can see this because I didn't bold all of this stuff, so I'll probably read through it. But this discussion really revolves around an article written by Oliver Sacks, which is called Scotoma on Neglect and Forgetting in the History of Science. And he talks about all of these different phenomena that he had observed as a neuroscientist that he found extraordinary, and they were very common in the kinds of researches he was doing. And yet when he looked at all of the literature in the area, nobody referred to any of these things. It was surprising to him. And so he came up with this term, which actually comes from neuroscience, that a scotoma is a disconnection or a hiatus in perception, essentially a gap in consciousness produced by a neurological lesion. And then he says that the deletion of what was originally perceived, a loss of knowledge, a loss of insight, a forgetting of insights that once seemed clearly established, a regression to less perceptive explanations. This is kind of his metaphorical notion of scotoma that applies to history. And what he argues, this very Kuhnian sort of point, is that there had been times in the history of medicine in particular where people were very interested in characterizing certain abnormalities, certain states, certain conditions, and they would record them with this wonderfully literary, voluminous prose where they would write about all these different things that had happened to some subject or other. And then later, other sort of fashions arose in that area that didn't like this recording of data. They liked things to be diagnosed, they liked things to be categorized and put in boxes. And because of that, many of these phenomena were forgotten for a long time. And Sacks has a nice quote from the great Gestalt psychologist, but also a great psychologist dealing with primatology, Wolfgang Köhler, had said that each science has a sort of attic into which things are almost automatically pushed that cannot be used at the moment, that do not quite fit. We're constantly putting aside unused a wealth of valuable material, which leads to the blocking of scientific progress. Let me talk about some of the scotoma examples that Sacks had mentioned, and again, I'm sorry about the lack of boldness on this slide. He was someone who suffered from migraines, and so he had an experience of this himself, and when he was dealing with patients, he found that many of them would report what he called geometric spectra. And he said about 1 in 20 of his patients noted this, but he could find nothing about it in the literature at all. It wasn't until he went back to the 19th century that he found all of these florid, rich descriptions of these geometric spectra, these very sort of repetitive geometric figures that would arise, you know, sort of prismatic-looking figures when someone's migraine was coming on. And interestingly, one of the people who wrote the most about this was the astronomer John Herschel, who suffered from migraines. And so he had these very long, intricate descriptions of it. And he actually said that he was not just an astronomer of the world without, but also the world within. And so he thought that what he was doing was internal astronomy. And people were very interested in this sort of thing, and then later it sort of all fell off, and nobody noticed it any longer. Nobody understood why they occurred, and then once there were cures that came up, once there were drugs that would cure migraines, then people seemed to be more open to understanding the phenomenology of migraines, but didn't really care about the causes for this kind of phenomenology, and that's why it was still something he didn't know about at the time. Interestingly, he also talks about Tourette's syndrome, and up until the 1960s, Tourette's syndrome had been entirely forgotten. It was given its name back in the 1880s. And it was only when Tourette's syndrome was seen to be a result of abnormal levels of dopamine that people had a nice mechanical, reductive explanation for it, then they started noticing it again. And so he wonders, you know, why is it that they lost all of this? And the only argument I'm making with this is that we can see that these are cases where people have had thousands of observations, carefully recorded observations, You can write them down, you can put them in journals, but if nobody cares about them, they disappear. And this probably happens in all kinds of other different areas of science as well. That's the case that I'm trying to make. Another case that he talks about, he had a mountain climbing accident, and he ended up damaging a lot of nerves in one of his legs. And he ended up having this strange sensation that the damaged leg was really not his, that it was some alien thing that was on his body. And he didn't know what to do about it, and he didn't know how to explain it to anybody. He was kind of traumatized by it, and he went and talked to his surgeon, and his surgeon said, you're crazy. Nobody has this kind of view. And to prove he wasn't crazy, he went back and read a lot of accounts from the Civil War in particular, in times when people were getting a lot of nerve damage. And sure enough, this belief that one's own limbs are alien was something commonly attested at that time. It was also attested commonly in World War I. As more use of anesthetics came around, less and less of this was reported. And so, as I'm arguing, I think the existence of this kind of thing, the existence of wholesale loss of all kinds of data, indicates that our development of knowledge, our growth in knowledge, and maybe even our growth in theory is retarded by all of this being lost as it is. Okay. Another thinker in this same line is Gunther Stent. And this is from actually a piece in 1972. He had a very stimulating article about what he called premature discoveries. And he says a premature discovery is a discovery whose implications cannot be connected by a series of simple logical steps to contemporary canonical or generally accepted knowledge. And he gives a number of examples of this. And he actually argues that it's a good thing that premature theories, or premature discoveries as he calls them, are gotten rid of. I don't like the term premature discovery because discovery is a success word. We might say premature hypotheses, an idea that somebody has that can't really be investigated yet. And one of his interesting examples is Oswald Avery's discovery of DNA in 1944. We all know about the celebrated discovery of the double helix due to Watson and Crick in the early 50s. But DNA had actually been discovered almost 10 years earlier. But nobody cared very much because they believed that DNA was a tetranucleotide, and they thought it was just monotonous, that there couldn't be any differing ratios of the bases within DNA. And it was only through Chargraph's discovery that this could be the case, that people then thought, hey, maybe this is the kind of stuff that can encode hereditary information. It didn't look like that when Avery discovered it. And so in a way, that was a premature discovery. Nobody knew what it was going to mean for quite some time. People knew about it, but they didn't care. And they started only caring once they had a big theory that could connect everything together. One that I'm going to talk about at some length are Mendel's discoveries in genetics. I'll talk about that in the next few slides, which is a pretty fascinating story. And then I'll also talk about a recently discovered manuscript of Einstein's. It was just published in February of this year that they discovered that he had written up a short little steady-state cosmology around 1931. And I'll talk about why that's interesting, but that was something that made people who study cosmology, fall off their chair. It felt a big shift in the force when they discovered that. And maybe if he had died right around that time, maybe if people had discovered the manuscript earlier, they might have taken steady-state cosmology much more seriously, much more early than they did, as a matter of fact. Okay, so let me tell you the charming story of Mendel. So here's a picture of him. You can see how ecclesiastical he was. He ended up being the rector of his monastery. And actually, when he became the rector, that ended his career as a scientist. And so it's an appropriate image to show. Interestingly, he repeatedly failed his teaching certification examinations. He passed in physics, he passed in chemistry, he failed in biology. No good at biology, okay? And he developed an alternative view of heredity to the dominant view. Everybody at the time he was working thought that when you took the two parents and put them together, that you sort of average the traits. which if that were true, if you had a father with brown eyes and a mother with blue eyes, they ought to be some weird mixture of blue and brown, but they're not, right? Our earlobes shouldn't be either attached or unattached. They should be in some continuous gradation between the two, but they're not. And his view was that the traits were actually these sort of discrete things. And he really came up with this view from doing all kinds of breeding of peas, as it turns out. He only published one paper. It was called Experiments with Plant Hybrids, which is such an alluring title that you can imagine why everybody read it. And it was in an obscure journal. It was in the little sort of province in what is now Czech Republic that he lived in. Interestingly, though, he did send about 40 copies to people he thought were really bright lights in the sciences, including Charles Darwin. And Mendel's paper is found unopened on Darwin's desk. He never read it. So that's a very interesting fact. But actually nobody read it. Nobody paid much attention to it at all. It sort of fell off into oblivion very, very quickly. 2 years after he wrote it, he became rector, and he stopped having time to sit out there in the garden and help these pea plants to pollinate one another thousands and thousands of times. And when he died, nobody thought much of him. They didn't think he was somebody who deserved immortality. And they took all of his letters, all of his papers that he had left, and they burned all of them. Interestingly, William Harvey, who discovered the circulation of the blood, who discovered it in 1616, but he only wrote about it in 1628, he had about 12 other treatises about medicine and biology that were burned because he was the official physician to King Charles I. So during the Civil War in England, they burned everything he had. And you might wonder what would have happened had some of those things not met that fate. We might wonder what exactly was going on in Mendel's head when he put all this together, but we don't know much about it. As I said, he did enough selective breeding to discover that peas have 7 independently inheritable traits. Turns out that peas also have 7 chromosomes, which there's no way he could have known, but he was a careful enough observer that he figured out what the various traits would be. Had to do with, whether the peas were smooth or whether they were sort of wrinkly, all these, the length of the stems, if they were short or long. He figured out all these traits by doing a lot of breeding. And he used his mathematical training, which he's very good at, to discover a 3-to-1 ratio of dominant to recessive trait inheritance. So in a way, he really unlocked the mystery of inheritance. Interestingly, in the 1930s, a Cambridge mathematician looked at Mendel's data that's published in his paper and found that his data was impossible, that he actually fudged it because there wasn't enough error. The noise floor was way too low. And so that's an interesting fact also, another colorful fact about Mendel. He did get a little bit of recognition. Carl von Nageli had read his paper and said, well, why don't you do the same thing with hawkweed? And it turns out, we now know hawkweed is an asexually reproducing plant. He would have gotten nothing from doing that. So that was not very good advice. And then in 1900, 3 independent researchers had done similar experiments to Mendel, and one of them, Hugo de Vries, then only noticed Mendel's paper, and so that's the only reason that we know about him. He'd have been completely forgotten without that. And so, again, this was published in 1865. Nobody paid any attention to it for 35 years, and we might wonder, what if nobody paid attention to it at all? What if he got made rector 2 years earlier, never published a thing? Would we have wanted to know due to his skill with gardening? And what he had to do was he had to put little hoods over the flowers on the peas, and he had to go up and get the, he had to go swab the insides of the flowers, from one plant to the other, to, move the pollen around in order to get them to cross-fertilize. So it was a very detailed botanical experiment he did over many, many years. We might have wanted to know what else he thought about all this stuff, but we don't. So maybe if we had his authoritative knowledge, we would be interested to consult him if we were back in 1870 or something. Okay, and then this Einstein case I'll talk about briefly. So Einstein had entertained a steady-state cosmology as early as 1931, and this predated the well-known cosmology of Fred Hoyle by about 15 years. In the 1920s, there was astronomical evidence that the universe seemed to be having everything moving away. You had the red shift, you had all this evidence to show that everything was moving out. And some cosmologists wanted to say there was this big singular event that started everything and then everything moved out. And a lot of scientists really hated that idea. Einstein hated that idea because he didn't think it was very general. Like, how do you have this thing and then it blows up and you have this other thing and you have a whole different set of laws? This is really inelegant. It's really ugly. And so while the idea that the universe in some sense never changes had been around since the beginning of anybody thinking about the universe, the steady-state cosmology is quite a bit different. It has this idea that you can have a conservation of matter and energy only within the realm of that which is observable to us. And so Hoyle had an argument with the Big Bangers. Actually, Fred Hoyle is the person who came up with the term Big Bang. Actually, he was trying to ridicule his opponents. He said that they were thinking of conservation of matter and energy within the whole universe, but why would we do that? We can only talk about the observable part, and so he came up with a theory that worked only for the observable part. It turns out that later in Hoyle's own life that there were astronomical observations that were completely inconsistent with steady state, and it's virtually dead now. But people wonder whether if Einstein's early views had been known, and actually he realized that he'd made a mistake in his general relativity calculations in the manuscript, and that may be why he dropped it, but nobody really knows. It might have helped Hoyle out, and so I quote, and again, sorry about the lack of boldness, I quote some of the people who are actually trying to publish the story about this. It still hasn't been published, but the article in Nature summarizes what would be published. They say this finding confirms that Hoyle was not a crank, says study co-author Simon Mitten, who actually wrote a very long and respected biography of Hoyle. The mere fact that Einstein had toyed with the steady state model could have lent Hoyle more credibility as he engaged the physics community in a debate on the subject. And then this Orafete, who actually made the discovery of the manuscript in the University of Jerusalem, had said, if only Hoyle had known, he would certainly have used it to punch his opponents. I should mention that Hoyle was often accused of being a crank. He believed that things like the flu and the cold coming on seasonally were due to the Earth moving through the asteroid belt, and that there were all these little weird particles out in outer space that got in here and they caused disease. And he said, why don't doctors take it seriously that diseases might be caused by cosmic factors? They're all so close-minded. And he was also at times a kind of evolution denier, and he was always getting in fights with people. He ended up resigning from Cambridge, and he sort of worked as a public intellectual. He was a writer of science fiction for the last 25 years of his life, but he was a total outsider. And so their point here is if people had known about what this other authority, the greatest authority there is, Einstein had thought, maybe they would have taken Hoyle more seriously, even though Hoyle was wrong in the end. That the history of things would have played out differently had he not been this loner. And you might also wonder if maybe Hoyle would have been taken more seriously if he wasn't such a wacko in a lot of other areas too. He might have had more indirect calibration if someone like Einstein had agreed with him. Okay, so let me enumerate three different ways that we might look at this kind of case and a lot of these cases. The first view is my view. I call it the rational view, but I'm not calling it that to honor my views. I'm only calling it that as a neutral description, because this is the view that there can be rational assertions of hypotheses. There can be rational consultations or entertainments of ideas that authorities had. So one might say that Einstein had good reasons for entertaining his hypothesis H, but only he had access to those reasons. And so we don't even really know too well what the reasons would have looked like. In the case of Kepler, which I'll talk about for just a second now, the case is much clearer. So Johannes Kepler had been the sort of helper or assistant to Tycho de Brahe, the great Danish astronomer, naked eye astronomer as well. Tycho never used a telescope, And Tycho had this amazing political clout for one period in his life, and then he had to move out of Denmark to what's now the Czech Republic in Prague, and he had a little bit of clout later, still more than most scientists had, but he ended up having this massive budget where he could build all of these wonderful observational devices, and the data he collected was thousands of times more accurate than anything that existed beforehand. In fact, Tycho was even shrewd enough to realize that when he was observing from his tower, the stone tower on the island of Hven off of Denmark, that his data wasn't as good as if he dug a hole in the ground and put everything down low where there was no oscillation or vibration to stop his data from getting through correctly. So he had this wonderfully accurate data. And these weren't the days where you just publish this on Twitter or something like that. You know, he had it all written down. And we now know that Tycho died of poisoning. People known this since the 1980s. Some people say he was murdered, but who knows why it was. He was an alchemist, so he probably was poisoned by his own mercury. They found in World War II the tomb he was in was bombed and it cracked open. And so they went in and they took some samples from his body, including hair samples, and they found that he had this large mercury spike. You know, forensic science could show that he had this huge mercury spike about 14 hours before he died. So he was poisoned. And when he died so suddenly, his helpful assistant Tycho took all the data and he ran away with it. And he said he had to do this. He was chosen to do this because Tycho's family would have just fought over it and destroyed it, and for the good of science, he had to do it. And when he finally came up with his new astronomy, he argued against all the traditions that had ever existed in astronomy that the orbits of the planets are elliptical. And he could only have made that argument based on that data. So if he had died, say he destroyed all the data and he died, we still would have thought, hey, Kepler's probably got the right hypothesis, even if he's the only guy who knows the data. So that's an interesting case. So we would have thought it was rational to consult his opinions as an authority. We could also enumerate a sort of oracular view, that we could just say, Einstein had this great creative power, he did all these great things, he discovered all this stuff, we don't know how the hell any of it works, we don't know how he thinks. He probably thinks so differently than us that we wouldn't understand it. I have a personal distaste for views like that. But it might be true. It might be that geniuses are just so different from us that we can't even conceive of what reasons they have. Maybe their reasons aren't reasons at all. Maybe it's just some crazed intuition that leads them to come up with this stuff. But we might still regard that person as a worthy authority, even on a view like that. Okay? So, and then finally, this is the orthodox view in 20th century philosophy of science. This is not really so explicitly held any longer, but I think it still kind of operates as a sort of quiet dogma for a lot of people, that there can't be any good reasons for putting the hypothesis forward. There are only good reasons for saying it's confirmed or falsified once we do some testing. And of course, authority wouldn't mean squat in this kind of view. If it did, it might be a case where we might be able to prove something a little quicker. We would get to things that are interesting to examine quicker than we ordinarily would, but that's about it. Okay? All right. One other thing I wanted to make a comment about, different ways of kind of understanding what it is to make a certain authorities' reasons or their hypotheses useful to someone else. There are different ways we could construe this, and we might distinguish two different ways of looking at it. We might say that K, which is Kepler in this case, has good reasons for entertaining H. That is to say, the idea that, or the hypothesis that Mars has a elliptical orbit. And then Bartsch, who was Kepler's assistant, just as Kepler was Tycho's assistant, we might say that Bartsch has good reasons for supposing one to be true. He has good reasons for supposing that Kepler is an authority, that he has good reasons for what he believes. And we could say that Bartsch is justified in appealing to Kepler if 2 holds. And 2 can be true even when 1 is not. He may have good reasons for believing that Kepler knows what he's talking about, even if, as a matter of fact, he doesn't. Okay? And so wording it in this way, it makes this argument not a contingent one, it's a logical argument, because anybody suitable to judge, so someone like Bartsch would have had to know a lot of astronomy to even make the judgment that Kepler knew what he was talking about, would come to the same conclusion. I'm going to skip a slide mentioning that, and I'll talk about Kepler again is a very colorful figure. When he was writing many of his books, he had to leave where he was in the Czech Republic, and he had to travel down to southwestern Germany because his mother was being tried as a witch. And so he was barely able to publish some of his works because of this weird travel schedule he had. And he had a lot of completely wacky views himself. So his first hypothesis, that Mars has an ellipsoidal orbit, we think, yeah, that's a good hypothesis. That actually turns out to be true. The second one, he believed that all the orbits of the planets are either inscribed or circumscribed by the regular solids, things like cubes, tetrahedra, dodecahedra. This is a crazy view. Why would these weird shapes that Plato had called our attention to, the only 5 regular solids, why would they be somehow related to the orbits? He also thought that there were these native spirits that made the planets move in and out when they went around the sun. Those don't seem like particularly good hypotheses to us. Why? What's wrong with them? Well, we could talk about a few things that distinguish the good ones, and then we could talk about the Martian orbit as meeting many of these requirements. So the hypothesis is concerned with phenomena that have yet to be adequately explained, and it seems capable of explaining them. So all of these cases where the orbit of Mars departed from what we would expect if it were circular could be explained by the ellipsoidal orbit. And so related to this, the hypothesis generates something that's testable. We have some testable implications that we could look for. And then again, we could assess the authority of the expert. Does this person actually have expert knowledge? Well, Kepler surely would have had more knowledge than anybody else alive at the time because he knew the data. He was involved in collecting a lot of it. And then we could also imagine the case where some barrier might stop an authority from elaborating and pursuing the hypothesis. Kepler actually was almost blind. He had this bizarre congenital visual abnormality that caused things in his periphery to be sort of repeated over and over again. And so he was actually a very bad observer. And so he might have been in a situation where he would have been incapable of actually testing anything. He might have had to rely on somebody else to do that for him. Okay, so let me finally kind of talk about a few of the lessons that I think come out of this, and then I'll be done. Appeals to authority and scientific inquiry might be one of the only places where social epistemology or some indirect route couldn't be used. I mentioned this earlier in the talk. It might be a case where examination of history of science is really necessary. It also seems that if there are cases where we would have had good reason to pursue some hypothesis simply because of who put it forward, this might indicate that expertise might have something to do with something beyond mere facts. It might exist in the absence of facts. And if that's true, then our notion of what it is to be an expert will need to be broadened. And that's the part of the talk I wanted to get across, not just in history of science. I think history of science gives us a clear case, but in other areas we might think of expertise as not involving just facts, but ability to kind of see where one can go, a fruitful path one can go on, and what one can investigate and sort of add to our knowledge from investigating. And then finally, an interesting kind of question, we might wonder, how decisions concerning funding and research priorities and directions are actually involved in non-factually stable sorts of domains. So if we think about an NSF grant, somebody writes a grant and they say, I'm going to investigate something or other. What's being appraised is the probability that that investigation is going to produce new knowledge. It's actually forecasts that are being made about things that are not yet factually stable, not yet known. It may be that lots of facts are necessary for determining which look like good bets, which look like good ways to go in their research. But expertise in knowing which things are worthwhile doesn't seem reducible to facts at all in a case like that. Okay, so let me just kind of, I'll give a little conclusion here. This is the more philosophical conclusion to follow what I just had. Some of it's different entirely, but so I want to argue that arguments from authority in the context of inquiry, where things are not factually settled, are legitimate only when one has a good reason to suppose that this hypothesis some authority has is a candidate to provide an adequate account of something that's perplexing us. And so I'm arguing that if, insofar as we do know the hypothesis and we don't know it well, we don't often know it clearly, but if it shows some promise to be able to explain something or it's easily testable, better than other models that are out there, even just as good, then we might think that it's legitimate, it's logical for us to entertain those things. Okay, so I would appreciate any questions. I hope that this was clear. I ended up talking consecutively for,